Hey, Mr. Riley here with our next lesson here talking about rational numbers. And today we are going to talk about comparing and ordering rational numbers, deciding which ones are bigger and smaller. All right, so first we're going to look at what rational numbers means. I mentioned this briefly the other day. A rational number is a number that can be expressed as a ratio of two integers written as a fraction. Okay, so basically, if you can write the number as a fraction of integers, then it is a rational number. So anything that's already a fraction, obviously, is a rational number, and any whole number or integer, right, can be written as a fraction by putting it over 1. So that is a rational number. And most decimals, well, certain types of decimals are also rational numbers. Terminating decimals, if they end, right, if the decimal ends, we've learned in the last lesson that you can make that into a fraction by putting it over the place value, over 10, over 100, over 1,000. So no matter how long the terminating decimal is, you can put it over that power of 10 and make it a fraction. Repeating decimals, we did not go over how to convert a repeating decimal to a fraction because it's a pretty painful process. But just take my word for it that repeating decimals also can all be turned into fractions. Okay, like 0.3 repeating is 1/3, 0.4 repeating is 4/9. So anyway, so if it's all fractions, all repeating decimals, and all terminating decimals are rational numbers. All right, so you can fill in this little Venn diagram here on page 271. Remember, the Venn diagram means that everything in this first little circle of whole numbers is also included in this circle of integers. And everything in both of those is included in the set of rational numbers. So first you have whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? No fractions or decimals. So out of this number bank, which one of these numbers goes over here? That would be the 1. Okay, so 1 and 2 are whole numbers. Integers include all whole numbers, positive numbers with no fractions and decimals, and also negative numbers that have no fraction or decimal parts. So which one on the number bank over here is an integer? Correct, -1. Hopefully you said the right thing. Okay, so -1 is an integer. So is 1, so is 2, so is -3. All right, rational numbers then. Rational numbers are fractions or repeating decimals or terminating decimals. So 0.8, that's a terminating decimal. That one's good. 2.2 repeating decimal. That one's good. 1 2/3 fraction. That one's good. 85%, you could rewrite that as a decimal, right, as 0.85. And so that too is a rational number. So all of those go here. And I know I added that 85% onto the list because percents, as long as it's a percent that ends, is good too. Oh, there we go. I already did it. See that? 0.85 or 85/100ths. All right. So this is just vocabulary, right, of classifying numbers. So when we talk about rational numbers, we're talking about fractions and decimals. Okay. Fractions and decimals and percents. All right. So there is a thing to point out, though, that not all numbers are rational numbers. There are also a bunch of irrational numbers. Okay, and irrational numbers are decimals that never end and never repeat. Irrational numbers. And you'll talk a lot more about them next year. Okay, the Greek letter pi represents the most famous non-terminating, non-repeating decimal number. Right? Some of you may have, in previous years, have memorized a certain number of digits of pi. Okay, so I don't know very many of them myself. 3.1415926. That's as far as I go. Okay, some people can go further. It keeps going. It never repeats. It never terminates. it is an irrational number. And you'll learn more. Well, we'll use pi later this year. We're not really caring that much that it's an irrational number. Next year, you'll talk more about irrational numbers. All right. This topic, though, we're going to talk about comparing rational numbers. So if you have fractions or decimals, how do you tell which one is larger and which one is smaller? All right. So remember that they include all negative numbers too. So if it's two fractions that you are comparing, well, when you're comparing the sizes of these two numbers, the pieces need to be the same size. Okay, so that means that the denominators of the fractions have to be the same for you to just straight compare them by how many there are, right? So that's one point here. So if they are not the same, if they do not have a common denominator, same size piece, then you have to convert them, which we'll talk about in a second. All right, so which one is greater, or is it greater than or less than negative 1 5/6, greater than, less than, or equal to negative 1 1/6? All right, so first, a reminder of the greater than and less than symbols, right? The alligator eats the bigger number. The alligator eats the bigger number. So the other thing to remember is negative numbers go backwards on the number line. So they show that to you here. Right? If you're going between negative 1 and negative 2, that's where both of these numbers are. Negative 1 1/6, you get to first here, and then negative 1 5/6 here. The further left the number is on the number line, the smaller the number. Okay? So since negative 1 5/6 is further to the left, it is the lesser of these two numbers. And therefore, the correct symbol is the less than symbol, just like they said down here. The number line can help you on these really because negative numbers, to just remember that negative numbers go in the opposite direction. The bigger the absolute value of the negative number, the smaller the number, because it's going to be further to the left on the number line. Got it? Negative 5 5/9 and negative 5 1/9. You can use a number line if you want to compare these. So it'd be a good idea to graph these two things on the number line here. It goes from negative 5 to negative 6 over here. And you would split this number line, if you were going to graph these, into 9 equal spaces. 9 equal spaces. And which one will you get to first as you're moving to the left? Well, you go to negative 5 1/9 first. Negative 5 5/9, a little bit more than halfway. And so to write your answer, you should write the two problems with a greater than or less than symbol in between them. Depending on which one you write first, you might as well do negative 5 5/9 is less than negative 5 1/9. Okay. Ordering fractions, especially negative ones, to be careful with that. Now, these fractions had common denominators, so they were pretty simple. What if they don't have common denominators? Okay, well, if you're comparing 7/12 and 8/18, now sometimes these fractions are so far off that you don't even need to calculate to know which one is bigger and smaller. All right. But a lot of times, like these two, 7/12, that's a little more than a half, right? A little more than 6/12. And 8/18, well, 8/18 is actually a little less than a half. So I could use those benchmarks. That's called using benchmarks to answer this question. We're not going to have time to go through how to use all those benchmarks. Sometimes I've done that, but it's just really this year not a good use of time to try to get you to be able to do those things. If you can do it, that's fine. All right. But the safer way, no matter what the fractions are, the safer way to figure out which one is bigger is to get a common denominator. There's actually even a safer way than this, which we'll get to in a minute. But all right, so let's review here. How do you find the common denominator, right? The same size pieces if you're talking about 12ths and 18ths. Okay, we have to split these up now into pieces that are going to be the same so I can compare them. So that is finding the lowest common denominator, or the least common denominator. Now, you learned probably how to do this back in 5th grade using this prime factorization method here, where they break, you do a factor tree and you figure out which common factors there are in both. I don't do that. Okay. I go to the multiples of these two numbers. Okay. So I think about all the multiples of 12, 24, 36. I can go as far as I needed to. And then I go to the multiples of 18. 18 times 1 is 18. 18 times 2 is 36. And I do that until I get a number that's on both lists. Now, usually you can do this in your head, depending on how hard the numbers are, right? But once you have this number that's in both lists, that is the least common denominator. Okay, so that means we have to rewrite these fractions as 36ths. What do I do to 12ths to get 36? I multiply by 3. Okay, so 7/12 is the same as, you see they do that over here, is the same as 21/36. Okay, these are equivalent fractions. And 8/18, well, to get to 36 for 18, I got to multiply by 2. So I do that on the top and the bottom, and I get 16/36. Okay, so these are also equivalent, 16/36 and 8/18. And now I have 21/36 and 16/36. The pieces are the same size, so the one with more pieces is bigger. 21/36 bigger than 16/36. Okay. All right, so what's the challenge of these? Well, some people have trouble with the least common denominator. So I will post an IXL topic. This is good practice, so everyone's going to do it. If you're good at them, it will not take you long at all. If you're not good at them, then you need the practice, right? So finding the least common denominator of two fractions, look for the multiples of each denominator until you get a number that is on both lists. Okay, I think as you get further on in this assignment, it might ask you for equivalent fractions, but for most of them, you just have to say what the common denominator is. So the answer for this problem would be 8. Okay, good practice. And we're going to need to do this common denominator stuff later on because it is required when you add and subtract fractions also. So good review of that skill, finding a lowest common denominator of two fractions. Oh, so here's some got it's for you to practice. Greater than, less than, or equal to 5/6 and 7/9. So the first question, what is the lowest common denominator for these two fractions? 18 is the answer, 6 times 3 and 9 times 2. So the equivalent fractions are 15/18, right? Multiply top and bottom here by 3, and 14/18, multiplying top and bottom here by 2. So the answer is greater than 5/6, just a little bit bigger than 7/9, bigger by 1/18. Okay, next one. This one's not as difficult. 5 and 50 should be pretty clear what the common denominator would be, is because 5 goes into 50. So I can convert this fraction to 50ths. 1/5 is the same as, so the common denominator is 50. 1/5 is the same as how many 50ths? Multiply both the top and the bottom here by 10. So 10 50ths, and comparing 10 50ths and 7 50ths, then my answer is greater than 10 50ths greater than 7 50ths. And on this problem on a test or a quiz, you would be required to show this work, right? You can't just write the greater than or less than sign and not justify how you got your answer. All right, last one. Oh, negative numbers, so be careful because those go backwards. What is the common denominator of 16 and 10? Oof. I think that's going to be 160. So one thing that you can do if you can't find the common denominator very easily is you can always use the easiest common denominator. The easiest common denominator is found by multiplying the two. It's not going to be 160. It's going to be 80 because 16 times 5 is 80. So the common denominator here is going to be 80. So 5 times 16 is 80, so that means the equivalent fraction of 9/16 is 45/80. Multiply the top and bottom by 5. And for 7/10, multiply top and bottom by 8 and get 56/80. These are negative, so remember they go backwards now. So negative 45/80, is it greater than or less than negative 56? Negatives go backwards, so it is less. It is greater than, rather. This one is going to be further to the right on the number line. Okay, that's working with fractions. Usually more difficult for these types of problems. And one thing that you can do, since we learned how to do this in the last unit, is instead of doing this with fractions and common denominators, you can always convert these to decimals and then compare them. That's really the easier way to go if you're bad at fractions. Okay, now you'll have to practice some of this fraction stuff because that's what you do right now. But when you really have to answer the question, you could use decimals to do that, and that's what we're going to talk about next. So comparing decimal numbers or percents even. Okay, so in Mr. Huang's class, 20% own roller shoes. And in Mrs. Trevino's class, 5 out of 29 students own roller shoes. This is a really old book, isn't it? Which class does a greater fraction of students own roller shoes? What's bigger, 20% of the class or 5 out of 29? Okay, so in all of these problems, you have to compare the numbers in the same format. So we're going to compare everything in decimals. If you have a calculator, that is the easiest way to do this. Okay, so 20% as a decimal, you might remember back to converting fraction decimal percent, you move the decimal 2 places to the left. It's on the yellow sticky here on the side of the page, right? Move the decimal point 2 places to convert percent to decimal. So 20% is the same as 0.2. 5/29 to do that as a decimal, divide, this is like we did in the last lesson, 5 divided by 29, 0.1724, blah, blah, blah. This decimal keeps going, but I only have to go out far enough to compare with this 0.2. So I really only need to go to 0.1. Okay, do not round this to compare. Compare each place. So 0.2 is bigger than 0.1. So 20% is bigger than 5 over 29, meaning Mr. Huang's class has a higher fraction or percentage of students with roller shoes. Okay, here's another example. This time it's who likes to bowl. In the second period class, 37.5% of the students like to bowl. And in fifth period, it's 12 out of 29. Which class has a greater fraction of students that like to bowl? So we need to convert these to percents. So first, 37.5%. What is 37.5% as a decimal? 0.375. Move the decimal point 2 places. Like this. Okay. What is 12 out of 29 as a decimal? 12 divided by 29 in your calculator, you get 0.4137931034. This probably keeps going. I don't see any repeating pattern right now. Okay. How far do I need to go on this? Just to here, 0.4 is bigger than 0.3. So 12/29 is bigger than 37.5%, right? 37.5% is less than 12 out of 29, meaning that the 12 out of 29 class, fifth period class, has more people that like to bowl. All right, so that's comparing two numbers, fractions or decimals, comparing two numbers. Well, if we add more numbers in, then we can put these numbers in order, and we've done this before, okay? So if you have more than two numbers, then you keep comparing each one to the next one to put them in order from least to greatest or greatest to least, all right? So again, you use place value when you convert them all to decimals and use place value. That's how you can compare which one is bigger and which one is smaller. So the first thing to do is to rewrite every number as a decimal. Okay. And if you have to, you can add zeros on the end to be able to compare all of the numbers. Okay. So 3.14 and zeros. Pi is 3.14159 and keep going. 3.4 repeating goes on forever with fours, and 3.44 stops there and has zeros after that. Okay. So first off, we know that these two numbers, the 3.14 and the pi, are going to be the two smaller numbers because the tenths digit here is a 1, and these tenths digits is a 4. So these are already 1 and 2. Okay, but what order? Which one is bigger of between these two? Well, the tenths place is the same. The hundredths place is the same. The thousandths place, there's a 1 here and a 0 here, meaning that this is the smallest. This one is second. Okay. Then we go over here. These are 3 and 4. So again, tenths place is the same. Hundredths place, they're the same. Thousandths place, the 0 is less than the 4, meaning this one is third and this one is fourth. And then what you do is you reorder the numbers. They must be rewritten in the original format, right? The original way you were given the numbers is how you have to rewrite them for your answer. So it's 3.14 was 1, then pi, then 3.44, and then 3.4 repeating. So that's what your answer looks like. Okay? We will do one more example of these. Oh, but first, this is just a description of what we were talking about. Okay, so when you're comparing decimals, you just go to each place value, okay? And if they're the same, you go to the next one. And if they're the same, you go to the next one. And if they're the same, you go to the next one until you find a place value where the two numbers are different. And then that, if you have to add zeros on at the end, or if it's a repeating decimal, keep adding the repeating digits, then that's how you do it. Okay. So 21.51, just a little bit bigger, right? Because it's bigger in the hundredths place, bigger in the hundredths place than 21.507. Okay, so we got two more of these to do, I think. Order this set: 23%, 0.21, 1/4, and 1/5. Okay, and again, they all need to be in the same format to compare them, so make them all decimals. 23% as a decimal, 0.23. 0.21 is already a decimal. 1/4 as a decimal, you're supposed to know that one, 0.25. And 1/5 as a decimal, you really should know that one too. That's 0.2. If you didn't know it, 1 divided by 5 in your calculator. Okay, so once you have them all in the same format, I like to just label what order they're in. So this is asking for, remember, or make sure to check. Sometimes they'll ask for greatest to least. Okay, so make sure you're answering the question. This one wants least to greatest. So the first number will be the smallest of these. That's that one. Then this one. Then this one. And then this one. And so finally, then you rewrite these in the original order. So 1/5 is the smallest, then 0.21, then 23%, and then 1/4. So that's your answer. 1/5, 0.21, 23%, 1/4. And again, writing the numbers in the original format. Real world problem here as an example. Nolan is the quarterback. He completed 67% of his passes, then 0.64, 3/5, and 69%. List his passing numbers from least to greatest. Again, convert them all to decimals. And then that would be the lowest one, 0.60. Then 0.64, then 0.67, then 0.69. And so then rewrite them 3/5, 0.64, 67%, 69%. So order these numbers from least to greatest. 15/11, 136%, 1 7/20, and 1.4 repeating. In the first boxes here are each of these written as a decimal. And how far out do you have to write the decimal? Well, it depends. You don't know what you have to compare to, so just write it out a few places, and then if you have to do more, you can do more later, okay? So 15 divided by 11 in your calculator, 1.3636363636, okay? Could have put a dot, dot, dot here, okay? Probably don't have to go out further than this. 136% as a decimal. Move the decimal point 2 places. 1.36. 1 7/20. 1 point and 7 divided by 20 in your calculator, or if you remember what 20ths are, is 0.35, 1.35. And 1.4 repeating. I really don't have to write out past one of these because these are all threes in the tens place. So 1.44 is plenty. All right, so now we go to these boxes. So which one of these numbers is the smallest? Well, it's not this one. This one is the largest because it has a 4 in the tens place. So you could right away mark that off as the fourth, the largest of these values. These all have a 3 in the tens place. So then to the hundreds place, 6 and 6 and 5. So this one is smallest. Between these two, they're the same in the hundreds place. So then you go to the thousands place, and this one is a 0, and this one is a 3, meaning that the 1.36 is next smallest, and then the 1.3636 is third. Okay, so now I have them in order, 1, 2, 3, 4. Now I rewrite them in the original format. So the lowest number is 1 7/20. Number 2 is 136%. Number 3 is 15/11. And number 4, 1.4 repeating. Okay, so comparing numbers, whether it's two numbers or whether you're putting a bunch in order, convert them to decimals and use place value to figure out which one is larger or smaller. Don't forget about negative numbers, go backwards. And if you have fractions, you can use common denominators instead to compare fractions. But you can always use this method too. And there you have it.